So this is Kubernetes for the Mesos user. My name is Brian Hicks. I'm the CTO at Asterisk. We're a consultancy in St. Louis, and we do stuff related to cloud and scaling, dynamic scheduling, that kind of thing. We also do Elm, in case you're interested in front end. You can get me at brian@aster.is or at Brian Hicks on Twitter. That's our company logo. So fancy. Right, so we're just going to jump right into a demo and run some Kubernetes stuff. So I have here the Google Cloud console. I'm running this from Google Cloud. Normally I would recommend, just use Mantle because it's the thing we make. But if you just want to experiment with Kubernetes and don't want to make any changes, the Google Container Engine is a pretty good way to do that. So the main entry point into Kubernetes is the kubectl binary. So I can run this and I get a bunch of commands, right? The one we want is kubectl get, and you can get anything in the system using this. So kubectl get pods, and it shows that we're not running anything. Services shows that we're not running any services, well, except for Kubernetes, right? So we're going to go ahead and start off by running an nginx container. So that would be kubectl run nginx image equals nginx, and this will just come from the Docker Hub. Now, you never want to run without a version, so I'm going to use 1.10.1 of the nginx image. And I also need to say port equals 80, since we're exposing port 80. So deployment nginx created, and now I can run kubectl get pods. And you can see that we're creating the container, so I'm just going to go ahead and watch that here. So, cool. So it looks like it's running, right? So this is great. We're running a container. Neat. kubectl logs, and then provide this nginx 138618 partial ID. Oh, come on. Where's my mouse? There it is. So, I forgot. Providing a partial ID doesn't work in this case. So we don't have any logs here, and I can also run logs f, which we'll show in just a second. So we don't have service yet for this. Services and service, SVC, are synonyms here. So we're going to run kubectl expose deployment nginx, since it's a so-called deployment. Actually, let me show you that. Deployments. We have the scale and everything for this nginx deployment, which is quite nice. So we're going to expose it, right? So expose deployment nginx, and type equals load balancer. I'm using a load balancer service here because I'm using a cloud provider. So what it'll do is talk to the cloud API and provision an external load balancer. So that's quite nice. kubectl get services, right? And we can see that we don't have an external IP for nginx yet, but it's provisioning. kubectl get services watch. So this may take just a little bit, right? It doesn't tend to take too terribly long. But what's going on here is that we have a service, and that's something that will be in service discovery. And then we have a pod, and that's something that's the back end for the service discovery layer. So right now I can discover nginx internal to the cluster by using the cluster IP 10.219.240.25 and connecting on port 80 on that IP. Kubernetes uses these things called virtual IPs in it, and it uses an overlay network. I believe by default it uses Flannel, but don't quote me on that. Go look into the docs. So this one is taking a little longer than normal. So we're going to go ahead and move on, and then I'll get back to it. All right, so you can do most of the things that you do in Kubernetes, or I'm sorry, in Docker in Kubernetes. So kubectl exec does the same thing that Docker exec would do, right? So let's do kubectl get pods to get our pod, and then kubectl exec. And I forget the syntax. So exec, yeah, I'm gonna give it a pod name, which is still on my clipboard, and let's just run ps. Cool. So we can see that that pod has nginx and ps, right? And if I do exec -i-t for send standard in and allocate a sudo tty and run bin sh, I get a terminal. And this is just running on some host in my cluster, and I don't really need to worry about which one. So this has a nice effect, right? Basically, on your Kubernetes workers, you never need to allow SSH access to like your developers, because they have everything they need with kubectl, and you can limit the scope to which people can get in and out of those, right? So let's go check out that those services again, right? Okay, we still haven't provisioned our external IP, and for the sake of time, I'm just going to go ahead and ignore that. But when we curl our 10.219, whatever external IP we've got, eventually, let's actually see if it's, I can get some more info here. Service nginx. So created load balancer. Oh, hey, how about that? Like in between the time I pressed that, it worked. So 104.197.59.254. And we get the nginx status page, which is quite nice, right? So I'm gonna hit this a few more times. Then I'm gonna go back to the logs. So, ta-da! I have 5 HTTP requests in my logs. And when I'm done with this, so kubectl get, actually let's scale, right? kubectl scale deployment nginx replicas equals 5. So it's scaled, so now we can get deployments, deployments, and we have 3 available, which means they're running, and if we get our pods, we can kind of see that happening. We're a little bit behind the times here, but we more or less have it. So now when we kubectl describe service nginx again, we can see that we have these endpoints in there, and they're just there. And when we're done, we can just kubectl delete service nginx, and that will go away, and deployment nginx, and the nodes will be descheduled, kubectl get pods, and I'm back down to running nothing. So to summarize, we just spun up a bunch of stuff, and then we just spun it right back down. Easy as you like. We exposed that. We looked at running commands on an individual pod and looking at logs for debugging. So basically we've done 90% of the tasks you'll need to do for a deployment on a day-to-day basis. Okay, so that was the demo. So if you haven't heard of Kubernetes before, that was just a whole bunch of nonsense. Kubernetes is an open source platform from Google. I've emphasized a couple of things here, right? So open source platform for automating deployment, scaling, and operation of application containers across a cluster of hosts. So open source platform, application containers, cluster of hosts. Does that sound familiar, right? It sounds a bit like, oh, you know, that thing that, yeah, Mesos. Yes, it sounds like Mesos. And that's because it does a lot of the same things that Mesos does. And the point of this talk is sort of to compare the two, so A, you can get a better idea of which you should use in any given scenario, and B, so that you know what's coming up, because this is becoming quite popular. So the first thing we're going to do is we're going to compare the web interfaces between Mesos and Kubernetes. So this is not the Mesos interface, but the Marathon interface, and this is more or less what you always run when you're running Mesos. So you run your Marathon interface, and you see that you have, you know, your apps and your folders and all the status, and it's very nice. And if you need to, you can jump into the Mesos interface, and you can see the full logs. You can see everything that you need to run your system. It's a very good informational status display for your whole cluster. Now in Kubernetes, we have something called kubeui. And kubeui, I have to admit, is not as good as Marathon's UI. This is basically all you get. You can look at logs, you can see memory and CPU usage. You don't get a great overall picture of the system. This is one of the detail views, so I'm not exactly comparing apples to apples here. But you can do a lot fewer things with this Kubernetes UI than you can do with the Marathon UI. However, you saw what I was doing with the Kubernetes CLI, and you can do a whole lot more with kubectl than you can with a comparably scoped Marathon tool, which, to be quite honest with you, doesn't exist in an official form, right? Next, let's talk about scheduling. So, in Mesos, you may be familiar, it's a two-level schedule, and it's based on a pool of resources on top of a bunch of nodes, right? So our first step is workers, this pool of nodes, offer their resources to the masters. So that means we've basically got, 10 nodes with 1 CPU and 2 gigabytes of RAM each, means that the masters figure, oh, okay, I have a total of whatever that would be, 10 CPUs and 200 gigabytes of RAM. Not terribly bad. But the masters offer those resources individually to frameworks, and the frameworks think about it for a little bit and say, yes, that is something that I would like to be running on this resource offer. I accept it, please run this workload. And then the work just gets scheduled, right? Via, we can kind of assume magic, but there's a whole lot going on under the covers. And Kubernetes is different. It's what I'm calling a multi-step constraint-based scheduler. Now this is my phrasing of this, and there might be a better way to do it, but based on my reading and experience with this, multi-step constraint-based scheduler is not a bad way to put it. So the first thing it does when you get a job, like when I ran kubectl run, is we'll try and find the suitable nodes for a given pod. And after we find the suitable nodes, we'll rank the best nodes. So for example, we're using, by default, Kubernetes uses this bin packing strategy, where it will try to allocate work on the least busy node. So if you're interested, go watch Kelsey Hightower's demos of Kubernetes. He explains this by using Tetris pieces falling. If you're taking a naive approach and just stacking all in one container, it's going to get all the way up to the top of the Tetris board and you're going to lose the game. But if you have a little bit of thought around it and figure out what's least utilized, that's, literally how you play Tetris, so we're going pretty well here. But at any rate, we kind of try and bin pack to find the least scheduled, and then, again, magic happens, probably Docker or API calls, whatnot, and then work gets scheduled. So this is quite a different concept from the normal Mesos scheduling, but it's not too bad. And it actually means that we can have a scheduler with a view of the entire system rather than a scheduler with just a view of the resources. And we can do other fancy stuff, like we can have a different type of scheduler that says, I want a container to be running on every node in this cluster. And then it just says, all right, well, I'm going to go do that. So it schedules a pod on every node in the cluster. And that's a scheduling problem that can be solved because we're using a constraint-based scheduler instead of a two-level scheduler with a resource pool and offers. Briefly, the reason you can't do that in Mesos is because you can never guarantee that your framework is going to receive the offers necessary for you to schedule work on all the nodes, where in Kubernetes, you get this top-down view of the whole thing in your scheduler, and you can schedule whatever you like using the API. So next we're going to look at a couple of application definitions. Now, I know that Marathon and Aurora sort of compete. I've always used Marathon. I'm just going to go with the Marathon IDs, right? So we're going to call an app basic 0, and this is pulled straight from the Marathon documentation. And I'm just going to run this shell command. So while true, echo hello Marathon and sleep 5 seconds. And you're done, right? It needs a tenth of a CPU in CPU time with milli CPUs basically, so thousandths of one CPU time. and 10 megabytes of memory, and we want one instance of this, right? So the normal marathon logic applies here, like curlx post this up to /v2/apps, and you've got something deployed, or you will have it deployed when the scheduler schedules it, talking with the resources and everything, right? Where in Kubernetes you have this, and it's a little messier, right? So we've got this YAML specification where you can specify a whole lot more things. And specifically, everything in Kubernetes has to be in a container. That's part of the basic idea of the system, is that it's containers first. So we have our same things here. We have the name of basic 0. We have a image. It's still the Glider Labs Alpine image. And we have the same resource limits. So 100 millicPUs, or 1/10 of 1 CPU time, and 10 megabytes of memory. So this is equivalent, and not exactly equal because we have to run a Docker container, but this brings a lot of nice features. However, it's like you compare between the Marathon JSON and the Kubernetes YAML, and you're like, well, I wonder which one I would want to use on a daily basis, right? Probably the simpler one. This is where you can't compare apples to apples, actually, because the Kubernetes YAML is if you want very strict, tight control of what's happening exactly, and you can do some very custom, nice things to get your apps scheduled and running exactly as you want them. But sometimes you just don't need that. Sometimes you just want to run while true do echo Kubernetes sleep 5 done. So then you tend to use kubectl. And in here, we have basically 4 arguments, just as we had in the Marathon JSON. So we start with a name, we have an image, we have limits, and then we have, we have limits, and then we have a double dash, everything after which is ignored, and we have a command. So we're running the basic shell with this string, right? And this works just fine. It'll be scheduled in the Marathon, in the Kubernetes cluster, and if you destroy it or the node goes away, it'll get rescheduled, just like all these dynamically scheduled systems, right? So that's kind of comparison of the image formats. So the last thing we're going to go over is when to use Kubernetes, also called K8s or Kube, and when to use Mesos. And I should go over this real quick. You'll see K8s a lot, K8s. It's because Kubernetes is kind of a long word, right? So there's a K, then there's 8 letters, then there's an S. K8s, right? It's just a simple way, but people will call it K8s, Kube, K8s, or just Kubernetes. So if we want fault tolerance, like I just talked about, I think we've pretty much got a tie. In Mesos, we have the regular Mesos fault tolerance that Twitter has demonstrated at scale among other companies like Airbnb and Apple. And if we destroy containers or pods, although we don't have pods in Mesos, but if we destroy these things, they'll just get rescheduled. And that's just how the system works, right? So yeah, it is quite fault tolerant. If you're running data frameworks like Spark or Hadoop or Cassandra even, you're going to want to use Mesos. Right now, those schedulers are very, well, I won't say very mature, but they are mature, they are stable, they are specialized in ways that doesn't require a whole lot of customization on your part. Whereas when you're running in Kubernetes, currently you kind of have to customize the image or find a pre-customized image that you have to rely on being updated as you need to upgrade your versions. Where the Mesos kind of has the same problem, it's not nearly as much, right? So I would say the win goes to Mesos in this case because it just makes data extremely easy to run. However, keep your eye on this because this is something that could change pretty easily. For 12-factor apps, K8s wins hand down, right? So 12-factor apps being your classic, like, 2-layer Ruby on Rails with a PostgreSQL backend kind of thing. Kubernetes has environments and secrets and service discovery and everything that you would want to use to build a proper 12-factor app. And, it kind of goes like that. So K8s wins here. The UI, as we've discussed, Mesos just kind of has a better UI. It has more information, it has more ways of getting the information, And Marathon's UI is great for scheduling jobs and controlling exactly what you want in a friendly GUI. But if you want a better CLI, K8s wins. Just hands down. kubectl is very, very good, and you can do a lot of things in it. And in fact, the K8s CLI just uses the Kubernetes API server's REST API to communicate. So if you need to build something yourself, you can just do that, right? You don't have to be running protocol buffers and whatnot like from Mesos. Just something to consider. Next, if we want IP per container, this being, right, let me state the problem here. Say we have an Nginx web server, and we want the Nginx web server to run on port 80. Now, if you're running this in Mesos by default, you will have to have a host port and an internal port. So it'll probably bind to internally, which Docker will forward to like something in the 10,000s, 20,000s range of ports. And then you have to use your service discovery to discover that port. Now, wouldn't it be nice if you had an IP per container so that each container had its own port space? And this is what IP per container does. So basically, in Kubernetes or a bolted on system on top of Mesos, you can use an IP per container, which means that when you bind to 80, the service is available at this container's IP on port 80. There's no poking of things needed, right? Everything just sort of works. So I would call that kind of a win for Kubernetes because it has it involved by default. You can bolt this onto Mesos, like I mentioned, but it is right now very much an afterthought, and it's kind of hard to integrate. So IP per container goes to Kubernetes. And multi-tenancy, finally. If you've tried to do multi-tenant Mesos, you know how painful that is, especially because all of the APIs are unauthenticated, whereas Kubernetes APIs default to being authenticated, and you can give scoped access tokens that have, for example, if we are running our 20 CPU, 200 gigabyte memory cluster that we were talking about before, you could have 2 developer groups and say, well, you each get like a total of 3 CPUs and 75 gigabytes of memory. And those resource limits would be enforced per token. So contention is no longer such a big deal, and everything can kind of be running in its own little isolated namespace, and that's what they call them, namespaces, and they don't discover each other's stuff unless you expose it globally. So this can be quite nice, especially for separating like your dev containers from your production containers. Not that you'd want to run them in the same cluster, but potentially you totally could run dev and staging together. So this is the point in the screencast where I would have said, like, do we have questions? But since we're not doing this in person, I'm just going to go ahead and say that you can email me at the email address brian@aster.is, or you can tweet at me, or if you just respond to the thread that I'm going to post this in, I'm sure myself or Paul Otto will be able to answer them or find an answer for you. So go ahead and reach out to us asynchronously, and I'm sure we will get you the answers you want. Anyway, thank you.